This video is about location planning and analysis. Location planning and analysis is a critical factor in operations management decision making. If you want to set up your business, maybe headquarter, maybe distribution center, warehouse, retail, or your manufacturing factory, how do you make this decision? And why is this even important? This is important because location related factors, they incur cost to company, and actually it's one of the strategic factor. Location can give strategic advantage to a company, or it can be a disadvantage to company. Now, for instance, most of manufacturing, it happens in China. Apple does its manufacturing in China. Why is that? It's not only just Apple, but many automobile companies, they also operate outside USA. Some operate in Mexico, some operate in China, and in other countries. The reason is that because they think that other countries provide them a strategic advantage. One of the reasons for this strategic advantage could be law, their regulatory factors, which mean in some countries there are labor laws are less stringent, cheap labor is available, and environmental standards are different. For instance, many Asian countries and underdeveloped countries, they are not very strict on pollution standards. But many Western countries in the US, they have strict laws for pollution. So which means many companies would find it more difficult to compete if they operate in the US. Similarly, another factor is pool of skilled people. And actually, once upon a time, Tim Cook, who is the CEO of Apple, asked by someone that why don't you move manufacturing to the United States? And he said it's not possible because the type of infrastructure we need, the supplier network, supplier base, and pool of skilled labor that is available in China is not available in the US. Therefore, we cannot move to, to the US. Another example is for instance, Detroit in Michigan. What it is famous for? It is famous for automobile companies. Many automobile companies, they have their assembly lines and business in Detroit. What is the reason for that? First of all, there's a historical factor, and then there's proximity to raw material that's easily available there, and supplier network is also established there, and a whole infrastructure exists, and also research and development is also going on. So as a result of that infrastructure, many automobile companies, they would find it more convenient to have their assembly lines or businesses to be set up in Detroit than another place. So the point is that location related decisions are strategic. They can give a company a competitive advantage. And because this is something that's directly related to cost, poor decisions would increase the cost, and good decisions, they can bring cost related advantages to the company. Now the next question is that how to make this decision. Well, all these things and these decisions, they boil down to one factor, that's cost. So which means all these strategic location decision, they should be based on cost, which means we will be calculating cost, we'll be using different models, and we will see any alternative that gives us lower cost or more profit, that would be our location of choice. Usually companies have these options. Sometimes companies, they find it more convenient to keep doing their operations in their home country. Sometime one option could be outsourcing. Outsourcing has both advantages and disadvantages. Advantages that when a company is doing outsourcing, they can focus on their core competencies. They don't have to focus on some other thing. They can outsource some activities to those people who have expertise in that area, and they will focus on their core competencies. For example, Apple has found that they should focus more on design part. That is the critical part. As far as manufacturing part is concerned, it can be done in another country and it could be subcontracted to another company like Foxconn. So one option could be that companies they would expand an existing facility when they are making these decisions. Another alternative could be that they add new location while retaining existing facilities. And the third one could be that shut down one location and move to another and do nothing. And again, the criteria in all these cases would be cost. Now, we'll be using two types of models. Is this one whereby we'll calculate total cost, and total cost is the sum of fixed cost and variable cost. Fixed cost, by definition, it means it is the type of cost that remains unchanged and it's independent of the amount of production. So it does not vary by amount of production, but it is a constant cost. So, for example, rent or lease, if you have leased some machines and you have to pay their lease, that will be another example of fixed cost. Then, salaries of people. I'm not talking about part-time people, but some people who would be there always be there. Their salaries is also an example of fixed cost. And then organizations they have to pay for insurance whether their business is high or low, they have to pay for insurance. That would also be a fixed cost. And then loans payment, which mean organizations they have to pay back their loans. And so all these things are fixed. And the next is called as variable cost. So variable cost by definition is the cost that varies by amount of production. The more you produce something, the more will be variable cost. So, for example, if you are running a restaurant, in a restaurant, if there are more customers, you are producing more meals. And when you are producing more meals, you are using more raw material. You might be using more raw material, more chicken, meat, spices. The amount of these ingredients is directly related to the number of customers. If there are more customers, which means these ingredients they will be used more, and therefore variable cost, which is usually given as variable cost per unit, it's multiplied by quantity, and when we sum them up that gives us total cost. Now let's say here is an example that has been taken from the textbook, and the example says a newly formed firm must decide on plant location. There are two alternatives under consideration: locate near the major raw materials or locate near the major customers. Locating near the raw material will result in lower fixed and variable cost than locating near the market. But the owner believes there would be a loss in sales volume because customers tend to favor local suppliers. So you see, it looks like here's a trade-off. In one situation, cost would be low, but on the other hand, there are also customer-related preferences, which mean customer prefer more locally produced food. So your decision involve a trade-off, and it should be based on cost. Revenues per unit will be $185 in either case. Using the following information, determine which location would produce the greatest profit. So we have these two alternatives, these two options, Omaha and Kansas City. And here we have our data. Annual fixed cost is 1.2 million in Omaha and 1.4 million in Kansas City. Variable cost, which is always given as per unit, is 36. And remember, we have to multiply this 36 with the volume or with quantity. We always have to do it. And variable cost in Kansas City is $47. And expected annual demand, that's quantity or Q, would be 8,000 in Omaha and 12,000 in Kansas. Given, and I will solve the first part. So our decision should be based on profit. Whichever option, whichever alternative, Omaha or Kansas gives more profit, we would choose that one. And again, for this one, I'll be using here Microsoft equation function. And you can see here, if you click on insert in the ribbon, here is equation. So you can click on that And if you do not want to do that, there are some other options. You can press Control and equal sign. In some keyboards, you have to press Alt and equal sign. So if I press Control and equal sign, I get this one, and it usually works, but sometimes you have to choose all linear. The formula for profit is, we know, that's revenues minus total cost. And by revenue, we mean price per unit multiplied by quantity. Let me write it in parentheses so that it appears as a separate factor, minus total cost. And total cost, we know, is a fixed cost plus variable cost, and variable cost, we know, is always multiplied quantity. Okay, now if I substitute here values, it will give us profit is equal to price per unit, and price per unit, we know, is $185. So 185 times how much, what's the demand? Demand is 8,000, and we are talking about this alternative, that's Omaha. So let me write it here in parentheses, Omaha. 185 times demand, that's 8,000, and then minus fixed cost is 1.2 million. So that's 1.2 million, and plus variable cost, it is $6. And you know, variable cost is always multiplied by demand. It will give you minus 8,000. So this is the answer that you will get once you solve this one, which means that if you go for this option, Omaha, there will be a loss of $8,000. Now you can repeat the same process with this option, Kansas option. And if Kansas gives profit, then we will choose that. Now, then there is another method that's called as center of gravity method. For example, let's say here we have a map. For this method, just imagine you have a map of the city, and this method is mostly used when you want to make a decision about where to set up your office or a distribution center or warehouse. Now, for example, just imagine in this situation, you are a supplier and you have to supply your products to different retailers, and these retailers, they are distributed throughout the city. So for example, let's say here's one destination, let's call it D1, and its coordinates are 2, 2, which mean on the x-axis, this is x-axis, and this is y-axis. So it's 2, 2, which mean here it is 2. On x-axis, it's 2, and on y-axis, it's also 2. So that's one retailer. Then there is another retailer, its coordinates are 3 and 5, which mean on x-axis, it is 3, here it is 3, and this is 5. Then retailer 3, and then retailer 4. For retailer 4, we have, let's say, 8 and 5, which mean on x-axis it's 8. So as you can see here, this is 8, and on y-axis it should be 5. As you can see, this is 5. Now you have to make a decision where you should be located, because you are a supplier. You have to supply these things where your distribution center should be, because transportation involves cost. And for example, just if you set up your facility here, then you'll be very close to D1, and D1 must be very happy because you are in close proximity to them. But D4 would be far away and they might have problem. So while your cost to supplying D1 would be low, but your cost to supplying to D4 would be relatively high because you have to travel huge distance. If you are located near D4, then exactly the opposite thing would happen, which means your cost to supplying D4 would be low, but cost to supplying D2 and D1 would be high. In this case, you have to make a decision where you should be located, where somewhere near D1, D2, D3, D4, or somewhere in the middle. And for this purpose, we use this method that's called center of gravity. So the starting point of center of gravity is that we start the map of the city and you pinpoint there where are different retailers. Okay, here is one retailer, or second retailer, third and fourth. And in the next step, we will take average of their axes. This question says a toy manufacturing produces toys in 5 locations throughout the country. Raw materials, which is primarily barrels of powdered plastic, will be shipped from a new centralized warehouse whose location is to be determined. The monthly quantities to be shipped to each location are the same. This is an important point here, because when quantities are different, then we will use a different method. A coordinate system has been established, and the coordinates of each location have been determined as shown. So which means they took a map, and on the map they spotted places, and then they found their coordinates. So these are coordinates. Location A has coordinates of x and 3 and 7, B has A2, C 4, 6. Now, where we should be located, what should be the optimal location of our facility that would minimize our transportation cost? And for this purpose, we will take average of x coordinates and then y coordinates. So here we have average of x coordinates will be 3 plus 8 plus 4 plus 4 plus 6, and these are 5 points. So divide by 5, that will be 25 over 5 is equal to x coordinate will be 5. In the same way, y coordinate is 7 plus 2 9, 9 plus 6 15, 15 plus 1 16, and 4 20. 20 divided by 5 is 4. So y coordinate is 4. Now in the next step, we will take a map and we will see where these coordinates would be on the map. Where would be 5 and 4. So for instance, if I say this is a map, this is x coordinate, that's 5, and this is y coordinate, y axis, that's 4, and 5 4 would be here. So which means that we should look for a location, maybe renting it or leasing it or buying our own property at this point, because that would be the optimal location to serve all those points that have been given in the problem. Another variation of the same problem is this one, where the problem is similar but the quantities to be delivered to each location, it varies. So for instance, let's say a company that handles hazardous waste wants to minimize the shipping cost for shipment to a disposal center from 5 receiving station it operates. Given the location of the receiving stations and the volumes to be shipped daily, determine the location of the disposal center. So again, we have these x coordinates and y coordinates, and this is the volume that is to be served to each location. Daily volume to be served to location A is 26 tons, and then 9 tons and 25 tons. Now in this case, because this volume is different, and this is a contrast from a previous question. In previous question, the quantities that was to be delivered to each location was the same, but here since quantity is different, so we have to factor in this difference. And for this purpose, we will multiply x coordinate by the volume. And even before that, one thing we will do is we will take the total of these 26 plus 9 plus 25 plus 30 plus 40, that's equal to 130. And then we will multiply 10 by 26, 4 by 9 plus 4 times 25 plus 2 times 30 plus 8 times 40, and then divided by 130, and that will give us x coordinate when volume is different. And then we will repeat the same process for y coordinate, which means y coordinate will become y 5 times 26 plus 1 times 9 plus 7 times 25 plus 6 times 30 plus 7 times 40, and they will be divided by 130. And then we will have values of x and y coordinates. Next step is go to the map and see where those x and y coordinates are on the map, and then you will be looking for location in that area or in the vicinity of that area, and that would be our optimal location.